Okay, so last lecture we already introduced the sum and the difference rule for cosine. So let's recall. So cosine alpha plus beta, cosine alpha cosine beta minus sine alpha sine beta, and cosine alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. Okay, so this is the sum and difference rule for cosine. And there is a detailed proof involving the the computation of distances. So we will not go through that proof. It's not required. We don't. Okay, so this is a general theorem. It works for all the angles. This is an identity. They are identities. They are identities for whatever angle you have this, and then we apply this and get some proof. So first of all, let's recall, if we have a right triangle, if this angle is the theta, this angle is pi over 2 minus theta. It's 90 degree minus theta because the total is pi. Here you already have pi over 2, so the sum of these two is pi over 2. And we know that the sine of theta is a cosine of pi over 2 minus theta, and the cosine of theta is sine of pi over 2 minus theta in the right triangle. And this is because when you change the angle, you change the opposite and adjacent, right? You change the opposite adjacent. Let's just use one thing. So this is A, B, and C. You see, sine opposite over adjacent. Cosine is adjacent. Opposite over hypotenuse. Cosine of pi over 2 minus theta is adjacent over hypotenuse. Okay, so this is correct, but we use a proof only in the right triangle. So we have our limitation. It's here theta should be between 0 and pi over 2. And now we want to show that this is also actually a formula, or this is actually an identity. It has no restriction. So establish sine theta equal to cosine pi over 2 minus theta. Sine theta is a cosine pi over 2 minus theta, and cosine theta is a sine pi over 2 minus theta. Okay, establish this identity. How? First one, you have this cosine. Okay, well, we start from right hand side because so far we only know cosine. So right hand side, right. It is equal to cosine pi over 2 minus theta, alpha and beta. So follow the formula. It's a cosine pi over 2 cosine theta plus sine pi over 2 sine theta. Right? So alpha minus beta, cosine alpha cosine beta plus sine alpha sine beta. Right? And then you recall cosine pi over 2. Always keep this in mind. Cosine pi over 2. 0. This is cosine. Sine pi over 2, 1. 0 times cosine theta is 0. 1 times sine theta is sine theta. Okay, this is left hand side. So right side after computation is left hand side. It's an identity. Right? Okay, so this is an identity. Then next, let's see how do we establish this part. Cosine theta is equal to sine pi over 2 minus cosine theta. So again, we can only manipulate cosine because we don't have formula for sine. So we start from the left hand side. But in this case, we have just one number. We don't have like alpha beta. We're going to apply our trick. Because we know if it's pi over 2 minus theta, it is equal to sine. So how do we get pi over 2 minus theta? We write this way, pi over 2 minus theta. Check here, pi over 2 minus parenthesis pi over 2 minus theta. This is exactly theta. You remove the parenthesis, it's minus and plus. Pi over 2 minus pi over 2 cancel, and plus theta is equal to theta. This is an identity, but it's trivial identity. Very useful. Okay, so now we are going to apply the first thing. Cosine pi over 2 minus whatever angle, minus this angle. Cosine pi over 2 minus this angle. From here, it is equal to sine this angle. Okay, cosine theta is sine pi over 2 minus theta. This is the right side. And check. Right? So this is a tricky proof. The reason we apply this tricky proof is that we don't have the formula, the sum and difference rule for sine so far. We don't have this. Okay, so that's the proof or the verification of some formula we already have. But before this, we only know the this formula correct for the acute angle. Now it works for all the angles. This is correct for all angles. These are identities. They are identities. Okay, so from this identity, actually we can get the sum and the difference rule for sine. The sum and difference rule for sine. So how do we do that? For example, I just do one computation. Okay, so sine alpha plus beta. Check here, sine theta is this, so it is equal to cosine pi over 2 minus this angle. Cosine pi over 2 minus this angle. Right? You have angle, pi over 2 minus angle. Sine becomes cosine. And we remove the parentheses, it becomes minus alpha and minus beta. And then we are going to regroup them. So I put pi over 2 minus alpha together and beta as the second angle. So it is a one angle minus second angle, cosine. So it's a cosine pi over 2 minus alpha cosine beta. Check here. The difference. You get a cosine to the first angle, cosine to the second angle. It is plus sine pi over 2 minus alpha sine beta. See? Sine alpha sine beta. Sine first angle, sine second angle. Right? Just consider this difference as first angle, the beta as second angle. Okay, and now you apply the formula we just established. Cosine alpha, pi over 2 minus alpha is sine alpha times cosine beta. And the sine pi over 2 minus alpha is cosine alpha. Okay, so that is the formula. And this is a proof. It's also the establish the identity. This is identity. So let me write down the theorem. The theorem, sine alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. sine alpha cosine beta plus cosine alpha sine beta. And the difference is sine alpha cosine beta minus cosine alpha sine beta. It's a difference. So we have 4 formulas. 2 sum rule for sine, cosine, 2 difference rule for sine, cosine. They are very similar. They are close to each other. Memorize them. It's very, very important. Okay? Okay. Example. Let's try to compute sine 7 pi over 12. 7 pi over 12. If you are not familiar with the reading, you can consider you can write them as degrees. 7 pi over 12 is 105 degrees. 7 pi over 12 is 105 pi degrees. 105 degrees. 105 degrees is 45 degrees plus 60 degrees. Okay, so this is pi over 4 and pi over 3. Okay, pi over 4 and pi over 3. Sine sum, so sine alpha cosine beta plus cosine alpha sine beta. Okay. Just take time to memorize those formulas. There's no shortcut. Okay. Sine pi over 4 root 2 over 2. Cosine pi over 3 1/2. Cosine pi over 4 root 2 over 2. Sine pi over 3 root 3 over 2. So it's a root 2 over 4 plus root 6 over 4. Okay. This is sine 105 degrees, or sine 7 pi over 2. Sine 7 pi over 2. To evaluate or to find such exact value, you actually just try to get the correct decomposition. Get a correct decomposition. Here you can write it as 45 plus 60. You can also write like 150 minus 45. What is 150? 150 is 5 pi over 6 minus pi over 4. Minus pi over 4. Yeah. So you can also do this, and then you will apply the difference rule for sine, and you also need to know what is the sine or cosine 5 pi over 6. Okay. It's not unique. It's definitely not unique. Next example, find the exact value of sine 80 degrees cosine 20 degrees minus cosine 80 degrees times sine 20 degrees. So sine alpha cosine beta minus cosine alpha sine beta. And this is exactly the expression of a difference rule of sine. So sine 80 degrees cosine 20 degrees minus cosine 80 degrees sine 20 degrees is exactly sine of 80 degrees minus 20 degrees. 80 minus 20 is 60 degrees. Sine 60 is root 3 over 2. Sine 60 root 3 over 2. So even though we don't know what is a sine 80 degree or cosine 80 degree, we have no idea. We don't know the exact value, but this combination, we can use the difference formula for the sine to evaluate. Okay. Next. It is known that sine alpha is 4/5. Alpha is between pi/2 and pi. Sine beta is -2/5, and beta is between pi and 3/2. Find the exact value of A cosine alpha. Let's do it part by part. So we know sine alpha is a 4/5, and pi is between alpha is between pi/2 and pi. This is the second quadrant. This is the second quadrant. Cosine alpha is negative. You see that all ASTC, right? ASTC. Cosine is negative. And then let's see, sine alpha is 4/5. So you get 4, 5. Then by Pythagorean theorem, it is a root 25 minus 16 is equal to 3. It's a root 9 is equal to 3. So this side is a 3. So the cosine alpha is going to be negative adjacent over hypotenuse, negative 3/5. Okay, so this argument gave us the negative sign. We know this cosine alpha must be negative. And then we need the cosine beta. Cosine beta, again, this beta, where is beta? Beta is between pi and 3/2. Pi and 3/2, the third quadrant. So cosine beta is also negative. Cosine beta is positive on the right side, negative on the left side. Okay, and after you determine the sign, let's see. Sine is 2 over square root of 5. 2 over square root of 5. This is 2, this is square root of 5. Then by the Pythagorean theorem, we can show that this side is 1. The third side is 1. The third side is 1, then cosine beta is negative 1 over root 5. Negative 1 over root 5. Right? Good. We have cosine alpha, cosine beta. And third part C, we're going to evaluate cosine alpha plus beta. The formula cosine alpha plus beta. Cosine alpha, cosine beta minus sine alpha, sine beta. So the sum rule. In the sum rule of cosine, it's a difference. Now let's plug in cosine alpha, negative 3/5. Cosine beta, negative 1 over root 5, minus sine alpha, 4/5. Sine beta, negative 2 over root 5. Right? Okay, so negative sign, they are cancelled. So 3 times 1 is a 3. Denominator 5 root 5. 5 times root 5. In this part, negative sign, they are cancelled. It's a plus. 4 times 2 is 8. 5 root 5. 3 over 5 root 5 plus 8 over 5 root 5 is 11 over 5 root 5. And this is the answer, right? Okay. Next. D. Part D. We evaluate sine alpha plus beta. Sine alpha plus beta is a sine alpha cosine beta plus a cosine alpha sine beta. Plus is plus. And sine alpha, where's sine alpha? Sine alpha. Sine alpha is 4/5. Cosine beta, negative 1/√5 plus cosine alpha, negative 3/5. Sine beta, negative 2/√5. Right? So it's a negative 4/5√5, negative plus 6/5√5. Here's minus, here's plus, so it's 6 minus 4. So the answer is 2/5√5. Don't simplify it in the exam. Just leave it as a final answer. Okay, so that's our evaluation. The evaluation. And we can also combine this with the establishing process. Establish the identity. Cosine of alpha minus beta over sine alpha sine beta is equal to cotangent alpha cotangent beta and plus 1. Establish this identity. Well, we start from the left hand side. And you have a difference of a cosine, so it's a cosine alpha cosine beta plus sine alpha sine beta over the denominator sine alpha sine beta. It's the left hand side. Ignore the right hand side so far. And then you see here, a plus b over c is of course a over c plus b over c. So you use cosine alpha cosine beta over sine alpha sine beta. Plus sine alpha sine beta over sine alpha sine beta. Okay. Of course, this term cancelled, you get a 1. Here you get cosine alpha over sine alpha tangent, cosine beta over sine beta cotangent, cotangent. And plus 1, this is the right hand side. You check. Okay, so let's establish of the identity. Combine the different combine the sine and the cosine, the sum and difference rule formula. We actually have the tangent. The theorem for the tangent sum and difference. Tangent alpha plus beta is tangent alpha plus tangent beta over 1 minus tangent of alpha tangent of beta. It's a sum. Difference tangent of alpha minus tangent of beta is tangent of alpha minus tangent of beta over 1 plus tangent alpha tangent of beta. Okay, so that's a sum and difference formula for the tangent. Well, we do have this formula, but possibly we don't memorize it a lot because it's more complex. If the formula is too complex, it's not that useful, right? If it's too complex, it's not useful. So we will only memorize sine and cosine. Tangent is like a byproduct. Okay, but let's just see one application of it. tangent theta plus pi over 2 is a cotangent theta. Okay, so how negative cotangent theta. So how tangent theta plus pi over 2, follow the table. So you get the tangent theta plus tangent, then you see here, this will give us a problem. If we directly apply this identity, we have a problem. The problem is tangent pi over 2 is undefined. It's undefined here. So the property is the sum formula cannot be directly applied. Instead of so this is not correct. Instead of using the formula directly, we are going to write it as a sine and cosine, because sine and cosine are defined over whatever point. So sine is sine theta cosine pi over 2 plus cosine theta sine pi over 2. Cosine is a cosine theta cosine pi over 2 minus sine theta sine pi over 2. Okay. Well, let's see. Cosine pi over 2, 0. That's the reason tangent is undefined. Sine pi over 2, 1. So here is 0, then the first term is 0. Here is 0, the first term is 0. Here's a 1, you don't write it. Here's 1, you don't have it. So after simplification, there's only cosine theta here. The denominator is negative sine theta. Cosine over sine is a cotangent. So that's a property. That's a proof. So we do have the tangent pi theta plus pi over 2 equal to negative cotangent. Negative cotangent. Actually, from the graph you can also see it. Remember what is a graph of tangent, like this. Tangent theta plus pi over 2 is tangent theta minus negative pi over 2. Minus negative pi over 2 means you are going to shift it to the left pi over 2. Left pi over 2 unit. And you can put this negative sign here. Then what is a cotangent? The graph cotangent is like this. Remember, it's periodic. It's cotangent. If you put a negative sign, you are going to flip. You are going to flip the graph. You see, that's exactly, well, it's a periodic, so that's exactly the same graph. But here is a demonstration, the graph demonstration, but that's not the proof. This is a proof. This is a correct proof. Okay. After we have this sum difference formula for the sine and cosine, and also we learn the inverse trig function, we can have some more complex computation. Evaluate or find the exact value of sine cosine negative, cosine inverse of 1/2 plus sine inverse of 3/5. Okay. So you just call this alpha. So let alpha be cosine inverse of 1/2, beta be sine inverse of 3 over 5. So two angles. Inverse trig is angle. The value is an angle. So alpha is cosine inverse of 1/2. So cosine alpha is 1/2. Cosine, that's the definition. And also we know that the range of cosine inverse is between 0 and pi. And the beta is a sine inverse of 3 over 5. So sine beta is 3 over 5. And the beta is between negative half 2 and the positive half 2. See here, you have to really know what is the range of inverse trig. Okay, so cosine alpha is 1 over 2. Then what is the sine alpha? Because in the formula, we will definitely use sine alpha and the cosine beta. Okay, sine alpha. 0 and pi, sine is positive, right? So sine alpha is positive. That's one thing. And second, from this triangle, you know that cosine alpha, my bad. This is alpha. Adjacent is 1, hypotenuse is 2, so the opposite is 3. So the sine alpha is opposite over hypotenuse. It's root 3 over 2. In this place, it's between negative half 2 and positive half 2. So cosine of beta is positive. It's a positive half 2, negative half 2. It's a first and a fourth quadrant. Cosine beta is positive. And okay, this is beta. Opposite is 3, hypotenuse is 5. By the Pythagorean theorem, you know the adjacent is 4. So cosine beta is 4 over 5. So keep in mind, you have this quantity, this quantity, this value, and this value. Okay? You must have those 4 values. Whenever you want to apply sine, cosine, some difference rule, some difference formula, you have to have 4 formula, 4 numbers. So sine alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Sine alpha, read it, root 3 over 2. Cosine beta, 4 over 5, plus cosine alpha, 1/2, sine beta, 3 over 5. So it's a 4 root 3 plus 3 over 10. See, that is the exact value. And next, let's solve an even more complex trigonometric equation. So we get sine plus cosine equal to 1. Theta is between 0 and 2 pi. So this formula has no square. Remember, it has no square. No square. You cannot use that Pythagorean identity to solve it. Okay, so since it has no square, let's square it, because we need a square in order to have 1. That's just so far that's all we have. So we square two sides. We get a sine theta plus cosine theta squared is equal to 1 squared. And this part, a plus b squared, is a squared 2ab b squared. Okay, so here you get a sine theta squared plus 2 sine theta cosine theta and plus cosine theta squared is equal to 1. Okay, the left hand side you see the sine square plus cosine square. This is a 1, so it's 1 plus 2 sine theta cosine theta is equal to 1. 1 from two sides, they are cancelled. You get a 2 sine theta cosine theta is equal to 0. Now it becomes 0. And you divide this equation by the coefficient of 2, you get sine theta times cosine theta is equal to 0. This is a formula. Now, it's not the answer, but this is a formula we need. Very good. So a product is 0. A product is 0. Then we get either sine theta equal to 0 or cosine theta equal to 0. Remember, theta is between 0 and 2 pi. Between 0 and 2 pi. Sine theta equal to 0 without 2 pi. Without 2 pi. So theta is 0 and pi. Cosine theta equal to 0. These 2 points. Theta is pi over 2 and 3 pi over 2. Okay? And remember, here, these answers are the solution of this equation. You square it, you get the answers. You must go back because you see here from this step you can go back and forth. Here you can go back and forth. Here you can go back and forth. But this place is just forward. You cannot go backward. Backward means you take square root. Take square root, it can be positive, it can be negative. So it's just one way. The rest of the steps are two ways. Only the first step is one way. So when you have the solutions, you have to check. Theta is 0. Theta is 0. Sine 0 plus cosine 0. Sine 0 is 0. Cosine 0 is 1. It's 1. Good. Theta is a pi. Sine pi plus cosine pi. Sine pi is 0. This is 0. Cosine pi, unfortunately, is negative 1. Bad. Okay, so cosine pi is negative 1. This is not the answer. Not the answer. Then pi over 2. Sine pi over 2 plus cosine pi over 2. Sine pi over 2 is 1. Cosine pi over 2 is 0. 1. Good. 3 pi over 2. Sine 3 pi over 2 plus cosine 3 pi over 2. Sine 3 pi over 2. Check here, check here, here. It's negative 1. Cosine 3 pi over 2 is 0. It's negative 1. Bad. So we have two good solutions, two bad solutions. So the solution the solutions are 0 and pi over 2. 0 and pi over 2. Not all of them, just 4 of them. Okay. So this is one way to compute it. What about the other way? The other way is application of trig identity, the sum and difference rule. So let's study it. Here, this is a tricky one. I mean, the first solution is also very tricky. We square it. Here, the tricky one is the following. We multiply this equation by square root of 2. We multiply the equation by square root of 2. And then we're going to consider the first square root of 2 as a cosine pi over 4. And second square root of 2 as a sine pi over 4. First is cosine, second is sine. And now you see, this is actually the left hand side, sine alpha cosine beta plus cosine alpha sine beta. This is equal to sine pi over 4 plus theta. Pi over 4 plus theta. Okay? And remember the theta is between 0 and 2 pi. And you let x be pi over 4 plus theta, then you get a sine x equal to root 2 over 2. X, you see, theta plus pi over 4, so it's between pi over 4 and 2 pi plus pi over 4. Sorry, here is also pi plus pi over 4, my bad. Sorry, x does not have. Theta, yeah. Okay, sine x is a root 2 over 2. What is the answer? X is pi over 4. Remember that whenever you have one answer for sine, it's pi minus pi over 4. For sine, it's always the angle and pi minus angle. For cosine, you have an angle and negative angle, right? We just did it last lecture. Okay, so and they are both inside this range. You see, it includes pi over 4, so this is the correct one. This one is also inside the range. It's a 3 pi over 4. It's inside. This is just one period, two solutions. That's enough. There's no more solutions. Okay, so when we get this, x is a pi over 4. X is a pi over 4 plus theta is equal to pi over 4. So theta is 0. See here, this is the first 0. And second, pi over 4 minus, plus theta is 3 pi over 4. You solve it, theta is pi over 2. And second solution. So it's the same thing, 0 pi over 2, 0 pi over 2. Same answer. This problem is not, this problem of course is a special problem, but it represents a class of a computation. We give you the idea, but we do not require this abstract process. So this is example on page 648. It's not required, but it's an idea. Why do we multiply two sides by this root 2 over 2? Why is it? So we solve a sine theta plus b cosine theta is equal to c. So in that problem, a, b, c are all 1. Here you have a, b, and c. Of course, we require a, b, c are non-zero. None of them is 0. If we have such a thing, we're going to divide the equation by square root of a squared plus b squared. Divide the equation, so we get divided. So here, you see, a is 1, b is 1, so we divide it by square root of 2. We divide it by square root of 2, you get a 1 over square root of 2. This part is 1 over square root of 2. 1 over square root of 2 is square root of 2 over 2. That's the reason we have such number. And then we're going to choose an angle. Choose an angle phi between 0 and 2 pi with cosine of phi is a over root a squared plus b squared, and the sine of phi is b over root a squared plus b squared. The reason we can do that is sine squared plus cosine squared is equal to 1. And that's the reason we divided the whole thing by square root of a squared plus b squared. Everything is artificial. Okay, then you get cosine phi sine theta plus sine phi cosine theta is equal to this number. And then you will have sine theta plus phi is equal to this number. Then you will start the computation. You will continue the computation. Okay, so that's the strategy, the process. And that's the reason we go through it. And there's some discussion how to find this phi. It totally depends on the AB, the sine of AB. So for us, we just require you to understand the concrete situation. We don't understand. We don't require this abstract computation. Okay, so that's the section 8.5. In section 8.5, we have sum and the difference formulas. They are all on page 649. There are cosine, sine, and tangent. We clearly require the sine, the different sum formula for sine, the cosine. We don't require tangent. You know it is there, and that's enough. Yeah, we require this and this. In the exam, for the exam, I require this. Of course, the formula for tangent is also required for your knowledge and research, but in my exam, we don't require it. Okay? So we still have a few minutes. Let's go a little bit step further. We study the section, we talk about a little section 8.6. Double angle and half angle formulas. Let's start from sine. This is the sum rule for sine. The sum rule for sine, what happens if alpha is equal to beta? If they are both theta, so we will have sine 2 theta. 2 theta, then this is sine theta, cosine theta. This is cosine theta, sine theta, the same thing. So that's our double angle formula. Sine 2 theta is 2 times sine theta, cosine theta. 2 times sine theta, cosine theta. The first double angle formula. Okay? So we apply this process for the cosine. See, cosine alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. And the same thing, we let alpha equal to beta equal to theta. So cosine of 2 theta is cosine theta times cosine theta square, minus sine theta times sine theta square. So cosine 2 theta is cosine theta square minus sine theta square. If you have a difference, it's cosine 2 theta. If you have a sum, it's equal to 1. Remember, that's Pythagorean identity. Cool. And we know that cosine theta squared by the Pythagorean identity is sine theta 1 minus sine theta squared. You plug in here, you get the second formula for the double angle. So it's 1 minus sine theta squared. This is cosine, and minus another one, minus twice. Right? And same thing, or similar thing. Sine theta squared is 1 minus cosine theta squared. And then you put it here. You get 1 cosine theta squared minus 1, and minus minus is plus. So 2 cosine theta squared minus 1 is also equal to cosine 2 theta. So these are 4 double angle formulas. So double angle formulas have 4 formulas. 1 for sine, 3 for cosine. Okay, 1 for sine, 3 for cosine. For example, let's try to compute. If sine theta is 3 over 5, theta is between pi over 2 and pi. The second quadrant. Find A sine 2 theta. Sine 2 theta. Sine 2 theta double angle formula is 2 sine theta cosine theta. So we already know sine, we have to find out cosine. What is cosine? In the second quadrant, cosine theta is negative. That's the first thing. You should know it's a negative. And second, opposite is 3. Hypotenuse is 5. Pythagorean theorem tells us the other side is 4. 3, 4, 5 is always a right triangle. So cosine theta is equal to 4 over 5 adjacent over hypotenuse, but with a negative sign. It's negative. So with this study or computation, we get 2 sine cosine. 2 times 3, 6, 6 times 4, 24. 5 times 5, 25. It's negative 24 over 25. Negative 24 over 25. This is our sine 2 theta. Okay, it's a sine 2 theta. B, cosine 2 theta. Cosine 2 theta is a tricky part because cosine 2 theta has 3 formulas. You have to select your favorite one or the best one. And here you see the problem only provides sine theta. In the second formula, you only need sine theta. So you are going to select the second one. So 1 minus 2 sine theta squared. 1 minus 2 times sine theta. What is sine theta? 3 over 5. And then squared. It's 9 over 25. 2 times 9 is 18. 1 minus it is 25 minus 18 over 25 is 7 over 25. 7 over 25. So cosine 2 theta is 7 over 25. So again, when you have cosine 2 theta, you must choose a proper formula from 3 formulas. If you don't, you may spend more time on the computation. Okay, so that's the tricky one. The sine is simple because sine there's only one formula. There's nothing you can select. Just use that. Okay. Okay, we'll stop here. Thank you.